Welcome to UGC NET and GATE Computer Science students. Here I'll be discussing system software and operating system part 4, which is related to how to approach 2020 June examination. Here I'll be straight away continuing problematic questions and how to solve it. And this was to July 2018. Consider a hash table of size 7 with the starting index 0 and hash function 7x plus 3 mod 4, assuming that hash table is initially empty. Which of the following is content of table when sequence 1, 3, 8, 10 is inserted into table using closed hash? Here a dash denote the empty location in the table. Okay, so it's actually very simple as well as algorithm. Actually hash following the function 7x, where x is we supposed to substitute 1, 3, 8 and 10. And so what is a hash table is nothing but, so it will be indexing totally 7 index 0 to 6. And if you are substituting this x value here, then you want to 7 into x is 1, 7 plus 3 which will be 10 mod 4 equal to 2. Okay, the answer is remainder. We supposed to we want to locate the second location in the hash table, and then we want to store this one as data. Okay, so that is the need of having this. And now second location will be occupied, and then 3. Okay, so 3 into 7 21 plus 3 24 mod 4 is nothing but what, 0. Okay, so now 0th location we want to fill 3. Okay, so second location we are filling 1, 0th location we are filling 3. Okay, so now 8 is coming. 8 into 7 is nothing but what, 49, 56 plus 3 59 mod 4 is what, so it will be 3. Okay, so now 8 will be filled at third location. Okay, I am filling. Now again 10 is coming. 10 into 7 70 plus 73, and remainder is what, 73, in the sense 3 is the answer. Okay, and now where we want to keep this 10 into 7 70 plus 3 is nothing but what, 73, in which 4 we supposed to make mod, so 72 for which we will be having how many time, actually 18 times 4 will be there, remainder is 1. so now first location we are keeping 10. Okay, so now these are the exactly placing this data in hash closed index, so this will be right answer. Okay, rest of the things in placed in improper place, so all those are wrong answer. Okay, so next one is, at particular time of computation the value of counting semaphore is 10, then 12p operation and xv operation were performed on this semaphore. If final value of semaphore is 7, what will be x value? Okay, and we have formula to find out such a x is nothing but critical section minus number of p plus number of v equal to total number of semaphore value. So here critical section for this number of count is what, 10. Okay, I am substituting here 10. So what will be x is nothing but 7 minus 10 plus 12. Okay, so because we are taking in right side, so it will be 9. Okay, so now answer B is correct. Okay, so next one is in a page memory, page it ratio is 40%. The time required to access page is secondary memory is equal to 120 nanosecond. Time required to access pages in primary memory is 15 nanosecond. Average time required to access pages. Okay, now very clearly, so what is the kind of problem here is nothing but there is a CPU which can access data from main memory directly. For that it will be taking 15 nanosecond. You suppose, suppose whatever record that will be present in main memory is nothing but it ratio. If not present, then you want to swap with your secondary memory and then you want to replace. Okay, so now whatever data, suppose I need 100% data, 40% data available in main memory, and so rest of the data will be in secondary memory. Okay, so if it is accessing main memory directly, then time record is nothing but percentage of data it have into time record to access the primary memory. So if it is not present in the main memory, and you want to go and look at what is called secondary memory, so for that how many percentage we are accessing from secondary memory is nothing but 60%, because it ratio is 40%, then it miss ratio is 60%, that is 1 minus it ratio percentage. Okay, so the formula is it ratio into primary memory access time plus 1 minus it ratio into secondary memory access time. So 0.4 into 15 plus 0.6 into 120, so totally we will be getting 78 nanosecond, and so D is correct answer. Okay, and next one is related to arrival time and something Poisson distribution ratio. In a multi-user operating system, 30 requests are made to use particular resource per hour on an average. Okay, then the probability that no requests are made in 40 minutes with arrival pattern Poisson ratio. Okay, and actually what the problem statement is 30 requests are made to use particular resource per hour, which means we can have 30 number of requests in a 60 minutes. Okay, and assume that no request made in 40 minutes, then what is the arrival pattern? Okay, so which mean we need to know so we know in 1 hour 30 requests made, in 40 hour how many requests will be made, so which is nothing but 20 requests. Okay, so next what happen is 20 is the number of requests sent in 40 minutes, so that is the lambda. Okay, so lambda equal to 20, but according to given statement actual requests are made in 40 minutes is 0. Okay, so for 40 minutes no request is made, so it is equal to 0, so which means x is equal to variable which will be 0. Okay, for 40 minutes, then your probability of no request made x equal to 0 is nothing but e power arrival rate into lambda power x divided by x factorial. So e power x lambda is nothing but 20 into x, lambda is nothing but 20 power x is nothing but 0 divided by x factorial is nothing but 0 factorial, so it will be e power minus 20, so that is the answer. Okay, so actually next question is related to page replacement algorithm. We discussed about least recently used algorithm previously in part 1, so you can refer there. Okay, I will be skipping this question. Okay, so next one is consider the following three processes with arrival time and CPU burst time given in millisecond, and arrival time mentioned and burst time mentioned. The constant for preemptive shortest job first algorithm. Okay, so that is a question, and very simply we can represent. Okay, and we are following shortest job first algorithm. So now shortest job here is P2, but it will be arriving at second 1. But what happen is here P1 arrive at 0th second itself. Then before this shortest job started, we supposed to perform whatever job in ready queue. Okay, so first you want to make completion of this P1, even it is longer than this P2 job, so you want to complete it first. Okay, so that is P1 we are serving. Okay, so how much time you want to serve is nothing but only 1 millisecond, because after 1 millisecond your P2 will be shortest time. Okay, so now 0 to 1 P1 we are working, remaining time you want to complete this task is 6. Okay, now P2 is we are completing it, and immediately followed by P1 we want to do. Okay, because 1 to 5, because 4 millisecond you want to serve for P2. After that P1 we want to serve for second time, so that is next least job. So but time is here 6, because already we performed 1 millisecond here, so 6 millisecond we are serving, so 5 plus 6 equal to 11, and completion task for P3 is 8 millisecond, so 11 plus 8 equal to 19. Okay, so now option 2 is very correct answer. I stop here. I will be continuing rest of the question in next part. Thank you.